Hey everyone, welcome to the channel. My name is Manuel, and today I'm excited to share a project that I've been working on for my PosTech at FIAP. This is the Phase 1 Tech Challenge, so let's get into it. Here is our problem statement. Our work involves analyzing Embrapa's winemaking data available on their website. The main idea of the project is to create a public API to fetch these data about winemaking areas. Our API will build a database for future use of machine learning models. So our required deliveries are create a REST API using Python. Our API must be well documented. We have to provide an authentication method using JWT. We have to draw our system architecture. And finally, we have to provide a shareable link to access our system. This is the sole talker about Embrapa's website. We have our main tabs here that our system will be aiming for: production, processing, commercialization, importation, and exportation tabs. We can notice that some pages have subcategories, and all the pages have a centralized table with winemaking information, and our system will be web scraping these tables accordingly. So let's get through our proposed architecture. Here on the left side, we have our app class that basically loads our Flask application with a proper configured JWT manager and the Swagger UI for documentation. On the right side, we have our routes and services layers. Routes layer is defined by routes registered on our Flask application. The full routes is composed by production and commercialization resources. They don't have subcategories. Exporting, import, and processing routes, on the other hand, are resources that have subcategories on Embrapa's website. Finally, we have our auth routes that manages users of the application. We are going through each one of these endpoints later. As we can notice on the services layer, we have a DuckDB service here. So DuckDB was the chosen database for this project. We have our auth service here for authenticate and register users. And we have also structure and scraper services. Scraper basically scrap data from Embrapa's website using Beautiful Soup. And the structure holds some business logic to scrap data from Embrapa's website if we don't have any data on our database, or to scrap data if we have a 30 minutes age longer data persisted. So we scrap data again and persist the new data here. And we also have a fallback mechanism to try to scrap data from the Embrapa's website, and if the website is down, we return the already persisted data from our database. So here is the main picture of our architecture, we have common users, machine learning models, AI agents, and other AI applications interacting with our application throughout our API. And down here, we have the others interactions with our mother database and the Embrapa's website itself. This is the README file. We have also a Portuguese version, and we can navigate through each version using this link here. And also we have our project structure listed, our requirements, and the steps needed to install and run our application. Looking to our projects folders, we can see the info folder here with several files, and also a README file containing all the steps needed to integrate Terraform and AWS, to provide an EC2 instance to deploy our app locally, or even using GitHub Actions. For this phase, we have deployed our app using Render, but after we demonstrate the API, we will also show you how to make this happen. This is our API Swagger running on Render. To use our endpoints, we have to register a user and then authenticate our user. So let's authenticate an already registered user. Take our access token here. Let's authorize ourselves. And now we can make requests to the others endpoints. So let's try the import table wines. You can try it out with or without a here input. So let's just execute here. And we got our response. As I was saying, our app was deployed using Render, but we can deploy it on an EC2 instance on AWS if you want. And for that, we just need Terraform installed on our machine and AWS access key and secret access key properly configured. So having that set up, you just need to open the terminal, get into our info folder, and then run a Terraform plan. And after that, we just need to run a Terraform apply. This will create our EC2 instance and all the infrastructure needed to open our EC2 instance connections to the internet. If we look on our .github folder, we have our workflows configured and pointing to feature / cloud deploy brands. Stepping into our AWS account, we can go to EC2, then dashboard, and we will see our instance running, and we will have to take note about our instance ID and our security group ID, and also our K-pair to proper configure our GitHub actions on GitHub. On GitHub, we just need to go to settings secrets and variables, actions, and here we have all the variables need to our GitHub action execute with success. Now we just need to create our branch, feature slash cloud underscore deploy, switch to that branch, and push it to our origin. So let's copy that, paste it, and we will see our GitHub action in a minute. So our GitHub action is running. We can also see the execution was completed with all the steps finished with success. Going to our public IPv4 DNS, we can see our Swagger UI running. And that was all for today. I hope you all enjoy it. I will leave the links on description. Thank you all for your time and see you next time. Bye bye.